Hey, and welcome back. So we're going to play a little bit with the equation we just generated in the last lecture. And we're going to go ahead and say for a first order reaction, the log of the concentration at time t is equal to minus the rate constant times the time plus the natural logarithm of where we started in terms of concentration. And if you are a math nerd, you might notice that this actually has the same form of the equation for a straight line, y equals mx plus b. And so what that means is that if you plot the natural logarithm of the concentration at time on the y-axis, and you plot time on the x-axis, then everything else lines up. So your y-intercept will be the log of where you started. So that's a constant. There we go. And the slope, right, is going to be the negative of the rate constant. So that is pretty awesome, right? So we can go ahead and we can take our data and we can go ahead and we can plot for a first order reaction, right? The log of the concentration versus time. So if the rate constant is positive, which it always is, then the slope will be negative. And so what we will find is that we will get a bunch of data points that line up, no pun intended, something like that. And we can go ahead and we can measure the slope of that. So we can do that with a spreadsheet, something like Excel. And we can see the slope is going to be minus the rate constant. And the y-intercept here, that would be the log of the original concentration, which kind of makes sense, right? Because this is time 0. But maybe we're running a reaction, right? And we find it very hard to measure the concentration at the start of the experiment. And so we can extrapolate back to figure this out. So what is really cool about this, and what is actually really kind of exciting about this, is that this is only a straight line if it's first order. And what do I mean by that? Well, if you've got a second order reaction, when you go ahead and you take the natural logarithm of the concentration and you plot it versus time, you end up not with a straight line, you end up with a curve. And if you take it for a zero order reaction and you do the same shebang, what you end up is with something that looks something like that. So it curves essentially in another direction. So what is this telling us? So actually, one thing it's really telling us is that if we plot log concentration versus time data and it's a straight line, it's actually telling us it's first order. In fact, we're going to do this in lab in a few weeks. So it can be used as a test for first order kinetics. Okay, so a plot of log concentration versus time is only straight if it's first order, and not only that, the slope is equal to the negative of the rate constant. So that's one of those things that you sort of have to remember, and that crops up a lot on the exams and on the final exam the ACS makes, that you've got to know, right? If you plot log concentration versus time and it's straight, what does that mean? And it means it's a first order reaction. So there you go.